But my laptop is basically like out of storage now because I've been downloading all these videos off of there and having to like compress them into like formats that YouTube. I mean, the videos start off as like 8 gigs, and so it's, but interesting enough, I suppose.
Figure out the settings thing to make it record longer?
No, 25 minutes seems to be the shut off. It might be relative to the app. So one thing I haven't tried yet, because you don't need to use the mobile app. What it does is it creates a Wi-Fi hotspot, and then you connect to it through your iOS or Android device with the app, and then you kind of control it remotely. But you can just push the button on the thing to say record. So it's possible if you do a manual thing that it'll record longer than 25 minutes, but I watched it hit 25 minutes and then the app killed it. So maybe it's the app doing it. I don't know what the scoop is, but what I kind of did for the presentations is I like for Zach's, I did everything up to when he started his transition from his slides to his demo. So there was that like 3-minute period there. I stopped it and started it again once his demo started. So we got the whole thing in. And then unfortunately, we only had 4 minutes of storage space left when Dover went up. So I'd be very, I mean, his was boring anyways. Yeah, I mean, very competent. He did something really cool, but not nearly as exciting as like VR stuff, right? Oh, it's a conference app. Right? Even though he did something pretty cool that's out of all of those is probably going to make the most money. But, whatever. Okay. So last time we talked about some internet technology stuff, right? And then you were pointing out that it was the day when we didn't have internet, which was the kind of ironic. Because what we were kind of focusing on is this idea of data over the internet. As we were kind of segueing into next semester, right? Most of you are going to be taking 250 next semester. I would highly, 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 highly encourage you to do programming over the summer. Find some project, pick something that you want to do in Python. If you really don't know where to start, reach out to me. I'll help you try to figure out a project or something like that, or give you some videos to go through some tutorials. Don't take the summer off of programming. Okay? Remember that programming is like a sport. So if you went to soccer camp and then took 3 months off of soccer and you go back, you're going to be pretty rusty, right?
Yeah. So in terms of trying to find places to where you can contribute anything in programming, there's a GitHub repository called First Contributors.
Okay.
Where you start kind of
how to become part of the online developer community.
Yeah. So
to contribute to projects.
Stuff, yeah. So
okay.
There will be issues or like bugs in the softwares, the open source softwares where you try to help.
Okay.
Fix some issues.
Will you put a link to that up on our Slack channel?
Yeah, for sure.
Yeah, and I'll check it out. Because one thing you do want to be careful of when you're first starting to do some of this stuff is you don't want to, for instance, I think I've gotten to know most of you in here at this point. None of us in here right now are ready to take on like the project Zach took on, right? But Zach was in the same shoes as you guys were several years ago. So you don't want to jump into that because that's, now it's like, okay, well, I learned how to shoot a free throw, so now I'm going to go and play in the NBA. Okay? Or maybe it's more like college hoops, but you get what I'm saying. So what you want to do is you want to always be challenging yourself, just kind of right outside of your reach, where you feel like it's attainable, but you're not really sure how to get there. Because then that's a level of research that you kind of know where to start. If you try to go to the NBA from knowing how to shoot free throws, there's a chasm in there, right? So you kind of got to know where to baby step it, and then eventually you end up, some top college player. Now you are kind of ready for the NBA. It ends up happening kind of naturally. So always just keep challenging yourself, and that's why your worst enemy right now, especially you're here for 4 years, and hopefully a lot of you go on to grad school. And we're actually I'll do an early pitch for it now, but we don't have the details worked out quite yet. But I think we will over the summer. We're going to be putting together an early start program for our master's degree, where as long as, I mean, so the idea is you have the opportunity to take several of our Masters of Computer Science or Masters of IT classes while you're still an undergrad as part of your undergrad tuition to get a jump start in the program so that when you graduate with your undergrad, you don't have much more to do to get your master's. Maybe it's 1 year, something like that, instead of 3 or 4 semesters. We're also looking at doing a scholars program where every year we'll maybe let 5 people in, similar to what the business school has, that they can complete the undergraduate and master's in 4 years. That's a kind of a second program we're looking at. But I think for everybody in here, if you are taking aggressive schedules, I mean, you're probably going to be looking at having to take 18 credits every semester. Your tuition covers 12 to 18, right? It'll be the type thing where be aggressive with your schedule so those last couple of years of school, you can kind of take 1 or 2 or 3 of our graduate courses, which are each, for computer science, each of those courses are 6 credits. So you need room in your schedule for a 6-credit class. And MSIT, they're 3-credit courses. There's just more of them. But the thing is, those credits can't double dip. So those 6 credits can't count for part of your total credits in undergrad, as well as 6 credits in grad school. All right, so you got to make sure you're meeting all of your undergraduate requirements, and then you can start getting a jump start on grad school so that when you come out, you're farther down the line. And the unfortunate truth anymore is that the bachelor's degree is kind of the new high school diploma, and the master's degree is the new bachelor's degree. It's just the nature of the beast. Because anymore, I mean, it used to be, let's say 20 years ago, that a significantly smaller percentage of people got bachelor's degrees. Now everybody comes out of high school, goes and gets a bachelor's degree. The schools are all businesses. They get you in the door, guarantee you 4 years out the door, and it is what it is. So I encourage you, if you're studious in nature, that's something that you want to kind of give yourself a leg up to kind of start thinking about, because I'm pretty confident that we will have that early start program probably starting in the fall. We'll have the details about that, but that's the scoop. Okay, so we've been talking about data representation languages. We talked about the internet last time, and really what we're trying to, I was saying a few minutes ago, is we're kind of thinking about segueing towards 250 next semester. So in 250 next semester, we're going to be switching languages over to the Java programming language, but we're going to be doing it in the context of Android programming. So we're going to start writing Android mobile applications. Well, how many of you have mobile apps on either your iPhone or your Android phone that doesn't connect to the internet in some way? Okay. Not very many, right? Most apps talk to the internet in some way. It does exist apps. Their apps do exist. They don't talk to the internet, but this idea of transmitting data from point A to point B must be pretty important since all of our apps do it, right? And how many of our apps that we've written in Python in here have done network communication? None of them, right? Okay, so it's something that we've kind of just ignored. We're like, let's focus on programming concepts, and next semester we'll keep focusing on new programming concepts and some new paradigm type stuff moving over to mobile application development. But now let's start bringing in some practical stuff that is, will help us do things that are really real life applications, right? So that's where kind of having this understanding of how data might be transmitted from point A to point B comes in, as well as this the concept of how big data is. A lot of us have this perception. So how many of you? We got a couple guys starting a game club here. I'm going to learn more about today. But how many of you play online games of some type? Battlefield or Call of Duty or whatever it is. Those are kind of the current popular ones for college students. It seems like shooters are very popular among college students. Has been my perception. But in any case, how much data do you think is being sent over the network when you're playing one of these games? Okay, so his feeling was a lot. Anybody else have a? Okay, well, so he fell right into my trap. So the perception is a lot, right? Now, when you install one of these games, how big is the install? That one's a lot, right? So when you install a game, whether it's a PS4 game or an Xbox One game, and you're downloading it over the network, or you put the disk in. I mean, it's downloading the 30 gig file or something like that, and then it does the install. But the footprint for a modern, AAA game is 20 or 30 gigs on your hard drive, right? And that's not uncalled for. And some of them are actually larger than that. Ones that are kind of some of the new 4K gaming type stuff. Why do you think a game would take up 30 or 40 gigabytes on your hard drive? Is that all code?
It's like physical. Like something like, imagine if we made a fully rendered version of Siemens application. It would be way bigger.
Okay, so you're using these weird phrases like fully rendered. What does that mean?
Like it fully detailed, I guess.
Okay. So is any rendering occurring in our Python cave crawler here? Technically a little tiny when it displays some words on our screen. The graphics card is doing some rendering. but the way he's using the idea of rendering, it's not, right? So how much of that 30 gigs in your game do you think is actually code? Not a whole bunch of it, right? Now your code does turn into a binary, so then you're going to convert. Once it goes through the compiler, it's going to turn into a bunch of zeros and ones that know how to be executed. It's going to go down to that low-level language of instructions that the CPU knows how to deal with. So if you wrote 10 lines of Python code or 10 lines of Java code, that might spit out into 300 lines of assembly code potentially. So it does increase in size when we start breaking it down to a binary set of instructions for our CPU, right? So the amount of code, our binaries, are going to be larger than we might expect, but not very big relative to that 30 gigabyte install, right? Fair enough. So what is most of that 30 gigabytes? He's mentioned this thing called rendering. Every year when new games come out, what's the major difference? I mean, if you play a first-person shooter, these FPS games, they're really all kind of the same, right? You run around, you shoot stuff. Some of them have like mini games like capture the flag or defend some goal or some of that. Some of them have storylines, but really you got a collection of weapons. You run around, you shoot stuff. Okay. So why do you keep buying them every single year? What changes?
They tightened up the graphics on level 3.
All right. So graphics, right? That's kind of one of the big things, right? They keep getting more and more realistic. And then some of them they kind of round this corner. So one of the things we've been noticing in technology is that sometimes the graphics get too realistic where it seems fake, right? Where that kind of, it breaks the suspension of reality. So what you end up seeing now is you see games that go for almost like cartoony realism, and then you have other games that go for kind of less human feature realism. So you have a lot of guys wearing armor and things like that rather than seeing a lot of facial features, because it kind of looks creepy to us when you see kind of a CGI rendered person that looks almost just like a person, but you can kind of tell they're not. Right, it's like a creepy vibe associated with it. But clearly, graphics keep getting better and better and better. What about resolution? When I say resolution of a game, what am I talking about? Huh? Okay, the ending, the other version of resolution. So things that make so we have this idea of graphics. And things related to graphics is we have resolution. What's resolution as it relates to graphics? Okay, well, it relates to image quality. But it is related to, but I'm not sure it has tons to do with image quality. So specifically, what is resolution? Give me some examples of resolutions you're aware of.
1080p.
1080p, okay. So 1080p resolution. What is 1080p resolution? Tell me everything you know about that.
Well, that would be, I believe, all right, so P means graphic scan.
Okay.
Not interlaced. The 1080, I believe that's the number of pixels in a line. Single scan line, not entirely sure on that. Generally, you'll see resolutions listed as, so many pixels high by so many pixels long.
Ah,
Say,
so what's the resolution of 1080p?
that I do
I think generally it would be 1920 by
1920 by 1080. So 1080p is usually what we call, up to this point, full HD. This would be equivalent to Blu-ray. All right, but now we have 4K Blu-rays, but it's actually not really Blu-ray anymore. It's actually using a different technology, but whatever. Okay, so this is full HD. The resolution is 1920 by 1080. Okay, that's the total number of pixels on the screen. So 1920 times 1080 gives you 2 million pixels. Okay, so we have 2 million pixels on the screen. Now, so that's full high definition. Now, you mentioned something about 1080i, right? 1080i is actually a lower resolution. That's 1366 by 720. I think it's 768.
Yeah.
1366 by 768. So 13, and it's about half the number of pixels. Okay, so that comes out to about half. If I did the math here, it'll come out to about half the number of pixels we just saw. What was standard definition TV? Remember when we had that? Or we always had HD as long as you've been watching TV?
No, we had it, but I don't think it had a name.
Well, it did have a name. It was called 480p.
Ew.
480p. Okay. So that was 640 by 480. So 307,000 pixels made up a picture. All right. So 307,000, and what was the other one? 2 billion. So 1920 times 1080 divided by 640 times 480. So the resolution of 1080p high definition, so Blu-ray, is 6.75 times the resolution of standard definition video, 480p video. What does that mean? When I say resolution, it's the total number of pixels, right? Total number of pixels on the screen. Now, what's the difference between a still image and a video? Frames. So still image is how many frames per second? 1 frame. Okay, so that means to have one 1080p still image, we need 2 million pixels, right? What's a pixel? What's one of these guys? Huh?
picture element.
Picture element. So maybe call it dot of color. Something like that. Okay, I mean, picture element is not inaccurate. Our picture is made up of a whole bunch of tiny little elements. They're called pixels, and each one is a dot of color. Okay, assuming we're dealing with a full color display. Otherwise, it could be a shade of gray or something in a black or white display. So a pixel is a dot of color. We'll come back to that guy here in a second. So let's operate off of resolution here. So 1920 by 1080, let's just get our number back out there. All right, so that's this guy. That's the number of pixels. All right. Now that is for a single image. Now you talked about something called frames, right? For video, we have a frame rate. What is the frame rate associated with a video?
24.
Frames per second. Movies are usually 24 frames a second. How many of you are PC gamers in here? All right. How happy would you be with 24 frames a second?
Depends on what you're doing.
No, we're not doing that at all.
If it's Mario Kart, maybe it's okay.
No, if you're running something extremely,
Doesn't
if you're really
Bejeweled.
if you're really
Is Bejeweled 24 frames a second is okay? All right.
Probably faster. If you're happy with 24 frames, then God help you out.
All right. So what are we happy with as gamers?
60.
at least
Nothing less.
at least 30. At least
Yeah,
30.
Okay. So you want a minimum of 30 frames a second. You want 60.
All day.
Okay, all day. You got a pretty good machine at home for gaming?
Yes, sir.
All right, what kind of graphics card you got?
It's old.
So your confidence just went down. You went from oh yes sir, a pretty good machine. Oh, a graphics card's old.
Pretty good for the games I play, which is like Skyrim. You know what I'm saying? I get 60 on Skyrim, like 60 on League. You get like 217 frames on League, right? But you know what I'm saying?
Okay, well, the problem there.
Okay, so hold on.
Bad game.
Yeah, let's go with this. So we'll operate off of your number. So forget it. Doesn't matter what your graphics card is. Something old but doesn't suck.
Right.
Right, 2 or 3 years old, something like that. Probably is worth a couple $100. And, you know, was $200 or $300 then. Now it's a $100 card or something, but it's fine. Okay, so we'll go 200 frames a second. Now you said you're happy with 60.
Yes.
All right. What do you think your eye can see?
24. Hold up.
Ish.
30?
Yeah, it's about 40 frames a second is what the human eye can detect. Now, having said that, if you are looking at a video that's going at 40 frames per second, and you're looking at something that's going 60 frames per second, there is a perceptible kind of jitter difference. You know, you can't necessarily see the frames, but you can kind of feel almost the smoothness. You kind of know what I'm saying? Because that's the real difference if you're a sports fan. And you go out and you buy one of these TVs, and you have the 60 hertz, the 120 hertz, and the 240 hertz TVs. Okay, what does it mean for a TV to be 240 hertz?
That's the pain level.
That's the pain level. So you kind of notice in technology we have all these buzzwords that are all over the boxes when you buy the big TV and stuff like that, but we don't know what they mean, right? 240 must be better than 120. It's twice as good. So why 240 hertz? Why is that better than 120?
Double the hertz, yeah.
Double the hertz, yo.
Is that the motion something? I'm not sure what
Okay, so we could think of hertz as maximum frames per second. I think it's a fair enough way of looking at hertz. So that means if you get a 240 hertz TV, it's capable of showing 240 frames a second. That's what it's capable of showing. Okay, that doesn't. I mean, very few sources are going to be pumping out 240 frames per second, but it could. So the selling point for those guys are if you're watching a lot of like sports. If you ever watched like a football game or a baseball game on a slower TV, like a 60 hertz TV, sometimes you almost see kind of the mirroring of the pitch, or the mirroring of the football. Well, you'll see the football like 3 or 4 times. You know, just barely. It's not like it's really there 3 or 4 times. You almost see like a trailing blur. Kind of know what I'm talking about? You won't see that at 240 hertz because it's able to refresh the screen fast enough that your eye can't keep up. Kind of make sense? So, I mean, that's the difference. So if the content you're watching isn't live action stuff like that, you'll probably never notice the difference. And I mean, I'm saying things very specific like that where you're paying attention to a ball. Okay, if you're watching Batman, a movie or something like that, chances are you're not going to see because there's a lot of stuff going on the screen at once. Okay, you're not focusing on this one little element. Does that make sense? Okay, so we were talking about 24 frames is what a movie typically is. A human eye is roughly capable of seeing about 40 frames per second. Yet you are claiming with a crappy old graphics card that you're getting over 200 frames per second in a crappy MOBA.
What?
League of Legends?
You
Yeah.
know what is crappy. I'll agree with that.
So why do you need that? Why do you need 200 frames a second? Just because you can?
It just feels right, you know? It just feels right.
It's because our buddy back here has a 1080 Ti graphics card, right? That's what you got? You have a 1080 Ti, you have the better one. You have a Titan. Okay, he has a ridiculous graphics card. All right? Yeah, so it's more than that. Yeah, so what kind of frames per second do you get on League of Legends, do you think? Does it just pop up the infinity sign? Huh? 200? Oh, so that must be the maximum it could even pump out at because he's tying you. That's how crappy that game is. Okay.
Some games that.
Or it's just well optimized.
All right, so why do you need 200 frames per second?
It just feels right. I told you, man. It just feels good.
Okay, so you're telling me that you're going to be able to tell the difference between 200 and 100 frames per
It's
second.
not about telling the difference, Dr. Lippman. It's just about.
It's bragging.
It's, it's bragging rights, yo.
Just glancing up, 214 frames per
When
second.
he
Like,
gets
man, that
stopped, he
feels good.
has to brag about something.
Wait, look.
What up,
I
yo?
can see myself dying
We could-
really fast.
We could make a program on his computer that just reads that in the corner, usually where you put that, it just reads off a constant 200, 300, regardless of whatever it actually
Yeah,
is.
right.
And it could just keep going up.
So now, realistically,
He could be running on 35 frames per second, say.
would we really be able to tell the difference between 100 frames per second and 200 frames per second?
No.
Probably not. But let's say you're playing a game and you get into, on average, the game is pulling 200 frames per second, something like that. And your same game is pulling 100 frames per second. Okay, and all of a sudden you get into a really, really busy area where your graphics card's really being taxed. Okay. Yours drops to 91 frames a second from 200. Okay, still good, still way clear what the human eye can see, right? Okay, yours drops to 30. Now you're going to start noticing jitter, right? You're not even living up to what your eye can see. Okay? That's why you get the crazy expensive graphics cards. If you're a big time gamer, you don't get it for the average case. You get it for the worst case. You can play, most middle of the road graphics cards can play any of the games for most of the time at a pretty similar level. It's under those heavy load times where the newest, latest, greatest games they've been working on for 4 years and had to guess 4 years ago what your requirements are going to need to be today. It's those games where you walk into a really crowded area with lots and lots and lots of people moving around, where your screen is constantly updating and lots of explosions are happening, all this stuff, that you want your card to be able to keep up. That's why you spend the money on the graphics card. Make sense? All right. So in a lot of these games, when you turn the graphics down, you get to set the graphics on low. What is it actually doing? Well, it's turning off shaders, it's turning off some pixel effects, and all sorts of the extra bells and whistles, right? I guess you're really hitting rock bottom if you're turning off color. But it's like, okay, we're going full black and white with this, and is there a way to convert everything to stick figures? So, then you might want to invest in a new graphics card. But under general circumstances, that's kind of why you get that. But when we talk about frame rate for graphics, the first number that kind of popped out here was 60 frames a second. So if we can kind of maintain 60 frames a second, then we're staying, comfortably clear of the human eye. Right? Okay, so frame rate is number of frames to show per second for video. And let's just give an example target of 60 FPS. So that means 60 frames per second. So 60 times that number is the number of pixels I have put in front of my face every single second. So 1920 by 1080 times 60. 124,416,000. Pixels per second. All right, so now we said a pixel was a dot of color. Well, how many different colors are there?
Yes.
Well, that depends. Which Crayola box did you buy? So when you go out and you get the Crayola boxes, you get the little tiny one, right? Initially. How many colors are in there? 12 or something like that, 16, a relatively small number. Or you get the 256 color one, right?
They just retired the color.
Did they? Like macaroni and cheese or something?
It was some kind of yellow.
I actually had a problem, a crayon related problem when I was a kid. Huh? Yeah, I used to eat quite a few crayons.
It must not do anything bad. I mean, turned out pretty good.
Well, I had the beholder.
Did they taste different?
I don't remember. My parents also tell me a story about me eating out of the litter box at some point. I don't know. I mean, I think kids do pretty stupid things, and you know, I think boys kind of do even stupider things.
My mom likes to remind me that when normal kids would draw on the walls, I drew on the carpet.
Yeah, yeah. I remember one time I had one of those sippy or the juice boxes with grape juice in it, and I accidentally squirted it up on our white ceiling. Okay, now, normal person was like, "Oh, that was a mistake. Let's clean it up real quick." No, I emptied the box all over. Yeah, I was 17 years old. No, I'm guessing that. I mean, that really happened. I don't know how old I was. I'm guessing 5 or something. So, anyways, we have a dot of color. So, when you think about colors on your computer, how many of you is 256 colors enough? Is 256 unique colors enough?
So my calculations are saying that there's 340 trillion colors. About.
Okay, in terms of so now I don't know a whole lot about this one, but I'm making the assumption. I think I've learned about this at some point, but the human eye can only detect a certain number of colors. Okay, but 256 colors by today's gaming standards is not enough, right? So generally speaking, when that would be 8-bit color, 256. 16-bit color would be 65,536 unique colors. Is that enough? A lot of our games are 24 or 32-bit color, right? So we'll keep this at worst case. Let's go 32-bit color. 32-bit color means there's roughly 4 billion unique colors that we're going to show on our computer screen. Okay? So that means each dot of color is represented as 32 bits. So we have this many pixels times 32 That's 3,981,312,000 bits per second of 1080p video. Well, that's if we're going to watch 60 frames a second of 1080p video, that's how many pixels are being, that's how many total bits of data our eyes are having to read in. All right, let's convert this down into something. So we'll go ahead and we'll divide this guy by 8. So that gets us bytes. Let's divide it by 1,024. That gets us kilobytes. And let's divide this guy by another 1,024. That gets us megabytes. All right, so 475 megabytes per second. If you wanted to go to gigabytes, now we're at, almost half a gigabyte per second of data that our eyes are slurping up. Okay? So we'll keep it at 474. So 475 megabytes per second of uncompressed data that our eyes have to see. Now, how many of you have ever watched a 1080p Netflix show or YouTube video or something like that? So maybe a movie on Netflix at 1080p. So let's say the movie is an hour and a half. So 90 minutes. All right. Remember, this is per second. So how many seconds are in 90 minutes? So we got 60 seconds in a minute, right? Times 90. So we have 5,400 seconds times 475 is 2,565,000 megabytes. Divided by 1,024, that's 2,504 gigabytes. Divided by 1,024, that's 2.45 terabytes. It's a lot of data. Now, do you think when you're watching Netflix at home and you watch a 90-minute video that your cable modem or your dial-up connection brought down 2.45 terabytes in that amount of time?
We should set the dial-up on fire if we did over a few gigabytes.
You would set a lot of stuff on fire, right? So 2.45 terabytes in 90 minutes. That's a lot, right? Now remember, we were at 475 megabytes per second. How fast of an internet connection do we need for 475 megabytes per second? 475 times 8, 3,800 megabit per second internet connection. So we're going to divide that by 1,024. You know how Google and AT&T currently offer gigabit internet? Well, we're going to need 3.71 gigabit internet, not 1 gigabit internet. So almost 4 times faster than the fastest internet right now in order to keep up with streaming 1080p. Now, how many of you have watched 4K on Netflix?
Isn't that it's not like within the same package?
Yeah, you have to upcharge it. But you know it exists, right? And can we make the assumption that it's worse in terms of the amount of data? It's sending more stuff with in 4K. So clearly, your internet at home is not downloading 2.5 terabytes in a 90-minute for a video. So what do we have to do? Compress it. So the video over here, the total amount of data we're going to have to send is 2.5 terabytes. We need to transmit that over the internet in the smallest package possible so that on this end, it can decompress it, still show it on your screen so that it looks good, looks high definition, so on and so forth. That make sense? So we have to look at various compression techniques for how do we squeeze 2.4 terabytes down to maybe 1.5 or 2 gigabytes. It's a pretty high compression rate, which then means what? On this end, you're going to need some sort of dedicated hardware in order to decompress that video. Hence your set-top boxes or your smart TVs that have a specific chip inside of them, a piece of hardware that knows exactly how to decompress video. You know, it has a chip that's specifically compatible, common standard is H.264. So it'll take H.264 compressed video and it can decompress it at hardware speeds because it's actually a computer program, if you will, built-in hardware that knows how to decompress video. All right, that's why we have our set-top boxes, your Apple TV, your Rokus, things like that. Same type of hardware is built into your smart TVs that's doing that same thing. So we kind of can start appreciating the amount of data that we're sending over the internet to do video. Now, this conversation kind of started by us talking about video games and saying, I asked the question of how much data do you think we're sending across the network for our video games? And you said a lot. You still think that's the case? So, but we said that the install of that video game on your local computer is about 30 gigs. Most of those graphics, most of that video, if you will, is stored locally on your machine. It's not having to transmit that over the internet. It's transmitting that from your hard drive to your, well, when you load the game, it loads it into RAM, which is faster, and then it's transmitting that to your graphics card, which is even faster. Okay? Your graphics card have like DDR5 RAM in it, and it's fast. Okay? So, what's actually being sent across the internet? little tiny packets of text. Just to give us our final punchline. What you might see getting sent over the internet for one of these games might be X is 15, Y is 32, Z is 67. Maybe just X, Y, Z coordinates for where your avatar is on the screen and where everybody else's avatar is on the screen. So you might have a collection. If you're in a room with 200 people, you might get this updated every, let's say 20 milliseconds. That's usually your ping rate, something like that. So every 20 milliseconds, you get another download of everybody's position. And then your local client draws everybody on the screen at that position. Make sense? The amount of stuff we're actually sending over the internet is just text data. Stuff like this. And remember what we've been talking about, just to put a bow on this, one of the problems with XML is it was too verbose, right? Too much fluff to describe data. This is a JSON format where we have just a whole bunch of name-value pairs. All right, and we'll talk more about JSON next semester when you take 250, but clearly this is less data than we would need for XML, right? All right, final exam is Tuesday or Wednesday? Wednesday at 10:10 a.m. Until noon. The exam will be very similar in format and length to the midterm. Okay, so about 10 questions, so time should not be an issue. You have the full 2 hours to take it, or hour and 50 minutes to take it, but it's designed to be a 50-minute exam. It's going to cover everything we talked about this semester with an emphasis on stuff we've talked about since the midterm. You cannot use the internet. You cannot use the internet. There will likely be a conversion question, so you might want to bring a calculator.
Is a phone for calculator?
The who?
Phone for calculator?
Yeah, you can use your phone for your calculator as long as you don't use Google. Just don't cheat. All right, I will see everybody on Wednesday.